Everyone, this is McKay Blovingood, and today I'm going to do a presentation on the Physics Lab 2 Lines of Charge. The main goals of this lab is to understand the interactions between two electrically charged pieces of Scotch tape through conducting an experiment. We're going to computationally simulate these interactions through the use of GlowScript and then determine the charge of the tapes and the electric force between them, as well as the gravitational force. Here are some important concepts and equations that we'll need to know. First, we have electric force and the gravitational force, and then E, which is the sum of all dE, which are the electric fields at certain locations, are all added together to get the total electric field. And then we have some constants, which K equals 9 times 10 to the 9th, and E, which is 1.6 times 10 to the negative 19th. Here in this lab, we're computationally simulating this experiment between the two tapes. So here are some specifications. The initial conditions are the tape mass is 2 times 10 to the negative 4th kilograms, the tape length is 0.2 meters, and the tape width is 0.025 meters. The system is tape B, and the surroundings is tape A and the earth. The assumptions being made are that air resistance is negligible and that the piece of tape has the same amount of charge evenly distributed along the length of the tape. And just to preface, before we get into the computation, the distance between the tapes was 0.0325 meters. Both tapes have a positive charge, and this was determined by the tape's attraction to the negatively charged plastic pen. Before the lab, I did some calculations. As you can see by the free body diagram, the net force is 0, the electric force is pointing upwards, and the gravitational force is pointing downwards. So these two magnitudes are equal and opposite, as you can see by my little equation. And then I did some algebra and rearranging to solve for the charge on one piece of tape, which ended up being 4.907 times 10 to the negative 8th. Now, for the coding, we start by initializing some values like K, G, mass, and Q, which we just solved for. And then later we have the function that solves for the E field. This was just done by using the equation we discussed earlier. Then we have the part of the code that creates the line charge. In this part of the code, we scale some of the vectors and the arrows that will be shown in the picture once we run the code, and then also we solve for dq and de on the top tape due to the dq on the bottom, and then the electric force is calculated on the top due to the bottom, and there's arrows for the net electric field that are being created in the code. And then also arrows to represent the net electric force on the top tape and the gravitational force on the top tape. And then at the end, we print these values. This code leads to this picture being shown, and then also these magnitudes of the electric force and the gravitational force being printed. As you can see, they are not quite even, and this is because there were some sources of error, like the weight of the tape is more of an estimate than an exact value. We're making the assumption that the tapes have a perfectly even distribution of charge, and additional forces from the surroundings are not being accounted for. From this lab and the code, we found that Q equals 4.907 times 10 to the negative 8th coulombs. The electric force is equal to 5.23 times 10 to the negative 3rd newtons, while the gravitational force is equal to 1.96 times 10 to the negative 3rd newtons. As you can see, the orders of magnitude for the electric force and gravitational force are the same, but they're not quite equivalent just because of human error and some errors within the lab. If each of the tapes had been modeled as a point charge like they were in the last lab, the calculated charge of the tape would be a smaller value. When treated as a point charge, we found that the tape had a charge of 1.52 times 10 to the negative 8th coulombs. However, when the tape was treated as a line charge, the charge of the tape was found to be 4.907 times 10 to the negative 8th coulombs. The estimates between the point charge model and the line charge model differ, as the line charge model leads to a larger calculated charge of the tape, as we just discussed. The line charge model is more accurate than the point charge model because it more accurately represents the distribution of charge along the tape, and it represents what's actually going on along the tape instead of treating the tape as a point charge. Thank you so much.